Imagine you're standing on the deck of a massive ocean liner, watching the waves crash against the hull. Or perhaps you are sitting in the cockpit of a Boeing 747, cruising at 30,000 feet. In both cases, if you ask the captain how fast you are going, they won't tell you in miles per hour. They will give you a number in knots. To most of us, a knot is something you tie in your shoelaces or a stubborn tangle in a piece of string. But in the world of global travel, it is the gold standard of speed. It is a unit of measurement that has survived the transition from wooden sailing ships to supersonic jets. But why? Why do we cling to this seemingly archaic term instead of using the familiar miles per hour or kilometers per hour that we use on land? The answer is a fascinating mix of history, geometry, and a very literal piece of wood. To understand it, we have to travel back over 400 years to a time when the ocean was a vast, terrifying mystery, and knowing your speed was quite literally a matter of life and death. In the late 16th century, sailors didn't have GPS. They didn't even have reliable clocks. Once a ship left the sight of land, the crew was effectively blind. They had to rely on a technique called dead reckoning. This involved calculating your current position based on a previously determined position, then factoring in your speed, your heading, and the time elapsed. But there was a massive problem. How do you measure speed in the middle of a featureless ocean? Before the invention of the system we use today, sailors used something called the Dutchman's log. It was about as primitive as it sounds. A sailor would stand at the front of the ship, the bow, and throw a piece of wood or even just some debris into the water. Then they would walk, or sometimes run, toward the back of the ship, the stern, trying to keep pace with the floating object. By timing how long it took for the ship to pass that piece of wood, they could get a rough estimate of their speed. As you can imagine, this was incredibly inaccurate. Every ship was a different length, every sailor had a different stride, and human error was rampant. If you miscalculated your speed by even a tiny fraction over weeks of sailing, you could end up hundreds of miles off course, hitting a reef or missing your destination entirely. The world needed a better way. Enter the chip log. Invented in the late 1500s, this was the first high-tech solution to the speed problem. The device consisted of three main parts: a wooden board shaped like a slice of pie, a very long rope, and a sand glass. The wooden board, called the chip, was weighted on one edge so that when it was tossed into the water, it would float upright and stay relatively stationary, acting like a temporary anchor in the waves. The rope, or the log line, was the secret ingredient. At regular intervals along this rope, the sailors tied actual knots. When they wanted to check their speed, they would toss the chip overboard. As the ship moved forward, the chip stayed put, pulling the rope out into the sea. One sailor would hold the reel, while another would hold a sand glass, usually a 28-second timer. As the sand ran through the glass, the sailor would feel the rope sliding through his calloused hands, counting each knot as it clicked past his fingers. 1 knot, 2 knots, 3 knots. When the sand ran out, they would stop the rope and look at the count. If 10 knots had passed through their hands in 28 seconds, the ship was traveling at 10 knots. It was a literal, physical measurement. This is also where we get the term logbook. Because the results were measured using this log of wood, the record of the ship's journey became known as the logbook, a term we still use today for everything from captain's journals to computer data files. But why were the knots spaced the way they were? This is where the math gets elegant. The distance between the knots wasn't random. It was carefully calculated to represent a fraction of a nautical mile. A nautical mile is different from the statute mile we use on land. while a land mile is 5,280 feet, a number standardized by Queen Elizabeth I based on the length of 8 furlongs. A nautical mile is based on the Earth itself. Imagine the Earth as a giant orange. If you slice that orange in half, you have a circle of 360 degrees. Each of those degrees can be divided into 60 smaller parts called minutes. 1 nautical mile is defined as exactly 1 minute of arc along any meridian of the Earth. In other words, it is 1/60th of 1 degree of the Earth's circumference. This makes a nautical mile roughly 6,076 feet, which is about 15% longer than a land mile. Because the nautical mile is tied to the Earth's geometry, it is the perfect unit for navigation. If a navigator knows they are at 40 degrees north latitude and they travel 60 nautical miles due north, they know they are now at exactly 41 degrees north latitude. There is no messy conversion, no complex math. The map and the distance are perfectly synced. So the sailors tied their knots at intervals of 47 feet and 3 inches. When you scale that up, 47 feet in 28 seconds, it perfectly equals 1 nautical mile in 1 hour. It was a beautiful piece of analog engineering that allowed uneducated sailors to perform complex spherical trigonometry just by feeling a rope. As the centuries passed, the wooden chips and ropes were replaced by mechanical impellers and eventually by satellite-linked electronic sensors, but the unit stayed. Even when the steam engine replaced the sail and the steel hull replaced the oak, the knot remained the universal language of the sea. But then came the airplane. In the early days of aviation, things were a bit of a mess. Many early pilots were former car mechanics or racing enthusiasts, so they naturally used miles per hour. Their instruments were often adapted from automobiles. For a few decades, you had a confusing world where some planes used miles per hour, some used kilometers per hour, and some used knots. However, as planes began to fly longer distances and cross oceans, pilots ran into the same problem the old sailors had. They were navigating over a curved Earth using latitude and longitude. If you are flying from New York to London, you're essentially sailing through the air. You're using the same charts, the same grid system, and the same geometry as a ship. In 1969, the International Civil Aviation Organization stepped in. They realized that for the sake of safety and global coordination, everyone needed to speak the same language. They chose knots. By using knots, a pilot can look at a standard nautical chart and instantly understand their progress relative to the Earth's coordinates. It also made communication with air traffic control much safer. There was no risk of a pilot thinking in miles per hour while a controller was thinking in knots. Today, whether you're on a nuclear submarine or a state-of-the-art stealth fighter, the knot is king. It's a bridge between our high-tech present and our adventurous past. It reminds us that no matter how fast we go or how high we fly, we are still just travelers moving across the surface of a great curved sphere. The next time you're on a flight and the pilot announces your cruising speed, take a moment to think about that 16th century sailor standing in the spray of the North Atlantic, feeling a wet rope slide through his hands. We've traded the hemp rope for fiber optics and the sand glass for atomic clocks, but the knot remains. A simple, brilliant solution to one of humanity's oldest challenges, finding our way home.